Okay, so let's look at the law of sines and where that comes from. And you guys have learned this at some point last year. Um, the way that I have it written here is sine A over A, sine B over B, sine C over C. That's one way of writing it. I tend to write it the other way around, though. I tend to flip all those fractions. So I get this version. And there's a reason that I like doing it this way. So the way that I want to derive it is by looking at a circle. So let me draw a circle here. And then there's a triangle that is inscribed in the circumcircle. So here's some triangle I'm going to draw. Right here. So A, B, C. That means that this side is little a, this side is little b, this side is little c. And the idea here is I want to figure out what the diameter of this circle is. So if I give you any triangle, you can always create a circle that goes through the three corners of the triangle, called the circumcircle. So my goal is to figure out what's the diameter of the circumcircle. Right? Remember, circum means around, so it's the circle around the triangle. Um, so we did this in class, and here's how we did it. Let's look at, I don't know, let's look at this angle right here, angle B. Okay, it's an inscribed angle, and the arc here that it intercepts, if angle B was x degrees, this would be 2x degrees. So I'm just going to say angle B is b degrees, so this right here is 2b degrees from here to here. Or not angle, that arc. That arc is 2b degrees, because you can measure arcs in degrees or in like inches. This doesn't tell you how long it is, it just tells you how many degrees it takes up out of the circle. And now if I sketch these radii right here, let's say that's the center of the circle. So there's one radius, there's the other radius. Well, this is now a central angle right here. I'm going to call the center O. So the central angle also carves out that 2b arc. So that means that central angles measure the same as the inscribed arc, or as the intercepted arc. So this one's also 2b degrees. Now I'm going to draw that triangle by itself in the center of the circle. So this is O, this is A, this is C. And I want to find the, what do I want to do? I want to find the radius in terms of capital B, little b, let's say. Okay, well, if I cut this side down the middle, since it's an isosceles triangle because of the two radii, I know that the side B got cut right in half, B over 2, B over 2. I know that my angle of 2B got cut right in half, B degrees, B degrees. So if I just look at like this triangle on this side here, right here, then I can set up a trig ratio. Let's do sine of B equals the opposite side, B over 2, over the radius r. Okay, so if I multiply the top and bottom both by 2 over 2, then this turns into b over 2r. So sine b equals little b over 2r. And if I do a little bit of rearranging, then I get 2r equals little b over sine b. And 2 times the radius is the diameter. So now I know that given this triangle right here, the diameter of this circle, if that's the center, and I drew a diameter all the way across, would be little b divided by sine b. Well, that doesn't really make any difference if we chose the capital B and the little b, or if we had chosen like capital A and little a instead, and if we repeated this same process where I draw in this triangle instead, and then cut this down the middle, I get A over 2 here, A over 2 here, capital A here, capital A there. And if I worked out this entire problem again, I'd get that the diameter is little a over sine of capital A. And if I did the same thing again, except this time I used angle C and side C, I'd end up with the diameter equals little c over sine capital C. And all three of these represent the same thing. They're all the diameter of that circumcircle. So that means that they're all equal to each other. A over sine A, B over sine B, C over sine C. A lot of textbooks leave off this diameter part. They just use this part. But I like, and this is the reason that I like writing the sides over the angles, because if you write it that way, then you are guaranteed to be given or to be able to find the diameter of that circle that fits perfectly around the triangle. And this is called the law of sines. The part in the big box. Okay. Hope that helps.